Question 9. Okay, and you're given a diagram of a car and it shows the horizontal forces. You're told the car experiences, the drag on the car depends upon its speed, and you're given a formula for drag, which shouldn't be too surprising to you because we have done something on this before. Okay, so the 0.3 is just a constant, which depends on all sorts of things, including the shape of the car and how dense the air is and so on. But that's a constant, and the key thing here is it depends on velocity squared. You're given the velocity here as well. It says at a particular instant the car is traveling at 20 meters per second. Calculate the net force on the car. Well, the net force is going to be a vector sum of the force in this direction plus the force which is in the opposite direction there. So now you're given this one, that's that one there, and that one is going to be due to the drag. And if it's due to the drag, it's going to be worked out or calculated by this formula. And you know what V is because it tells you the V from here. So you plug that into that formula, you find that, you find the net force, and there it is. And then the next bit is much easier because you just use the famous equation, oh, nearly gave it away then, which links F, M and A to find the acceleration. Right, now part B though requires a bit more thought. Okay, there's these equations of motion that you've seen many times before. And it says explain why you cannot use V equals U plus AT to determine the velocity of the car after a time t. Okay, well, when we first did these equations, I told you of the conditions where they work. Okay, they only work under certain conditions, and you gotta try and remember what that is. And I can't give you another hint without giving it away. So have a bit of a think about that.